Awesome. So today I'm going to be talking about going from pipelines to platform. I guess the real takeaway I want you to get from this is to really show that how over the coming decade, really the organizations that invest in science and invest in really software as the most important scientific tool will really create the breakthroughs in life sciences as well. So first off, though, I want to start with a little bit of a hello to Boston. It's very nice to be back here. So this is the third time we've done this. It's also a very special place. It's really a city that embodies what happens when you both invest in sort of tech-first culture, combine that with life science. So I'm going to be talking today about how software is becoming one of the key instruments in modern science, and how our work at Seqera is really helping to advance science for everyone through software. I'm going to see what that means, both in terms of practice, and also understand how we're moving towards this in a sort of AI-driven future that's unfolding now. Boston isn't just the host city, it's also a place where much of modern biotech was born. So thinking about some of the fantastic organizations that are in there, from Syme, created in Cambridge in the 1980s in terms of development of orphan drugs. We have folks at the Broad and the genomic moonshots that happened there. As part of this, you're able to get a huge amount of talent into this place, and it's really something which continues to kind of grow there. They may have a dubious taste in workflow languages, but we've got many of them at Seqera today. Also onto the likes of Ginkgo, and really thinking about this code of life bioengineering thing. The city really shows that when you take that engineering mindset, you combine it with cutting-edge research, and then you also add the capital investment, you can really supercharge science there. Okay, so with Nextflow, our goal is, in many ways, is really about exporting that sort of Boston-style fusion of software and biology. From containers to cloud, really want to give access to every organization, every lab, every budding scientist anywhere on the planet to be able to combine that software and science together. There's obviously a rich legacy of that as well. I'll just tell a small story. Many of you may know this, but I find it quite inspiring. If you look at what took place with Vertex there, and there was a mind sort of shift in thinking that led to the creation of Vertex. So now famous book that I'd recommend that you'd like to read. In 1984, there was Josh Boger here. He was a chemist up the road at Merck. He really started to think about what would happen if you could give chemists, in particular, sort of access and be able to use computational representation of small molecules to be able to drive things forward. So he really sort of had that idea, spent a lot of time early on these silicon graphics workstations, really the best computer that you could buy at the time, and then be able to do that, able to get this sort of rational design of chemistry. So moving away from having to spend hours in the lab doing computational chemistry there. And for me, when I think about things today, it's really this similar cycle where you have a digital hypothesis, and then you can go to a physical validation. And the more of that we can do up front in silico, obviously there's huge benefits to that and sort of efficiencies and savings. If we think about what's the sort of that physical validation today, this is one of the sort of the first drugs that was developed that came about through this rational drug design. But today we can prove and disprove so much, not just on small molecules, but on ever larger molecules. And you'll see that the models that people are using are able to just get larger and larger in terms of what we're able to feed into them, and therefore are able to get much more in silico prediction. So that kind of digital hypothesis is maybe more now in silico validation more and more. And software is a foundational piece to really unblock that bottleneck. So really the same spirit that the Vertex team showed is really what we're trying to channel here. It shows this example of where you can use software. It can be a very decisive part of your science, part of your lab. And our mission is really to give that scientific instrument, in this case software, to every scientist. One of the great things about software is the distribution model as well, because you can very easily give this out, and that's sort of one of the reasons behind some of the success of Nextflow as well. Thinking then more about why this is more important today than it ever has been. So if we think about some of the reasons that we're moving here today, we've collected like ever richer data sets themselves. Even things like new sequencing chemistries that are coming online really give us new ways to inspect and look at life. If you think about things like AlphaFold, they would not have existed, though, without the countless hours scientists who were crystallizing structures, submitting them to PDB. So there really has been a lot of work which we've really relied on to be able to kind of get to where we are today. And one thing I sort of got me thinking more on this topic was that it's incredible to think that there is incredible discoveries that are out there to be made based on public data that exists today, based on the tools that we have today. And in many ways, we just need the creativity and in some cases the ability to go and find those things. It's an incredible opportunity that we live in as well. Also, like with the data, we also unlock new capabilities. As it relates to a lot of the AI and ML companies, I just wanted to put some other public examples here, or ones that are spoken about more often. So if like in silico medicine here, really discovered this new drug candidate for pulmonary fibrosis in under 18 months to be able to do that. Accenture, they were able to design a drug that entered human trials in less than 12 months. So again, it's like this really kind of speed up that we're able to get. Meanwhile, folks over at Moderna have been building mRNA vaccines using this software-driven platform, lets researchers prototype vaccine sequences in hours. And then there's, of course, companies like Recursion who are really leaning into AI in terms of like the full scientific data lifecycle and really having LLMs themselves like actually designing the experiments here. So many of these things are all new, but I know that many in the audience will be adopting many of these things throughout your business as well. If we think about where we're heading with this, the kind of direction that we're going, richer data, more powerful models, I think the big question remains then, what does it mean to innovate in this future? Like, what do organizations and scientists need to do today to make sure that they're really staying ahead? And then also, what are the obstacles that we can help remove to enable this better science? And that's some of the things we'd be thinking about a lot at Seqera today. There's also, we have to be, in some way kind of considerate of the existing challenges that we see. One of them is clearly around the fragmentation of data. There's very often siloed, very different formats, and being able to access it there. There is rising compute demands, and sometimes shrinking budgets at the same time as those things are going on. So there's challenges that need to be handled. And then, of course, in regulatory settings, the importance of security and compliance and really streamlining that is some of the challenges that we're really kind of working and trying to tackle here. One way to think about this and the way we've been approaching this is try and understand through the kind of core pillars that we have. The first one is on building. Many of you were in this room today because you learned Nextflow, started building pipelines in that, and that building for scientists and bioinformaticians so that you can develop analysis and really, the investments that you've made in your scientific software to kind of get there. But it's really just one part of the bigger picture. There's also the need for standards. We want to make our science findable, interoperable, accessible, etc. And we want to be able to put that throughout not just the software part, but kind of more broadly in terms of how we're doing scientific software. And finally, there's the scale. We want to be able to run science on infrastructure that can handle both small-scale analysis, but also really large-scale analysis that kind of breaks out to larger teams, to more compute, and that's really the scientific infrastructure piece. So I'm going to go through each of these and also jump into some demos and invite some folks onto stage. But first, I want to start with build. I still think it's too difficult to build pipelines, quite frankly, and for many people that it's too hard and oftentimes too slow. There's a bunch of reasons for this. Bioinformatics itself is a little bit different. It has some peculiarities around it. Maybe you're using various tools that are not so well documented, dependencies. Maybe the software is not necessarily designed great in the first place. You've got 1,000,001 different formats. That creates a high barrier to entry for most folks. But there's one trend that we've seen over the last couple of years, and that's where more scientists who are coming out of college or university, they have some basic scripting capabilities. And if you think about that combined with some of the AI coding assistants that are out there, it can really kind of change the way that people build and interact and really kind of develop software here. Unfortunately, though, vibe coding is probably not going to get you your Nature paper alone. There's a lot more to it than that. But with agents, really these tools become much more than just regurgitating text. With agents, you can test if the pipeline actually runs. Are you able to connect it to real data, et cetera? Often it's still pretty difficult if you're using off-the-shelf tools, and really making sure if your colleagues will even be able to understand it or reuse it. So there's a big element of standards around that. Many of the things that make bioinformatics specific, or that are specific to kind of scientific software, are many of the things that we sort of built Nextflow for in the first place. Well, the reasons behind Nextflow, there's this concept of being domain specific for us. The idea that you want to connect it with data, often compressed text or semi-structured data there. You've got really a huge number of different libraries and dependencies you have. I think Bioconda is going to hit about 10,000 packages this year. And then you also need to be able to run those pipelines, so actually just be able to get to compute quickly, make the software accessible for a broader set of scientists, and then finally just the heterogeneous resource requirements that exist in much of the bioinformatics work that we do. So given all of these requirements, we sort of had a look at what exists out there in the market in terms of what you can do and how scientists are building scientific software there. And really over the past 12 months, there wasn't anything like that sort of fantastically sort of fit this use case that we were doing. So we've been building Seqera AI for the last 12 months. To share some of the most latest or recent developments, I'm going to invite Sasha on our stage. So Sasha leads up the AI team at Seqera. And Sasha's going to give us a little live AI demo.
Hi guys, my name is Sasha. Today I want to talk to you guys about pipeline mode. Now, can people guess what pipeline mode is about? That's right. So we are going to be talking about pipelines. Excuse me, this mic's a little, don't want to blow your ears out. So we are just going to be talking about pipelines, and pipelines today, right? And to show what the product can do, I don't just want to talk about it. I want to show the demo itself. And so what better way to start than just creating a new Nextflow pipeline? Now, this is where the experience is pretty typical for, and I'll just make this a little larger so people can see. It's pretty typical for most AI tools. And it asks what type of pipeline we want to create. Let's just do a simple RNA-seq 3-step pipeline. And so now Seqera AI's pipeline mode will give you a plan, and you'll get going. But this is where things are different, right? Evan, when you usually interact with, when you're starting out building pipelines, do you usually start wholesale from scratch?
There's a recommended way to do this is obviously start with some kind of template or some kind of structure that you have in there.
Exactly, and that's what we're doing here. So what Seqera AI's pipeline mode does is that it leverages NF Core tooling to initially build a scaffolding before starting out. Now, the scaffolding gives you a lot of things for free. One, it gives you a nice schema. Two, it gives you a folder structure that your colleagues will understand. So they'll know, hey, if I'm looking for a configuration file, it's here. If I'm looking for where the module files, they're probably in the modules folder. It all makes sense. And then the third thing is that it comes with a lot of preloaded settings, so that make it easier to run on AWS, GCP, or your university's HPC infrastructure. Now, the next part, though, is, again, very, very different for us, and that's actually adding in the modules into the pipeline. Now, if you were to ask another tool to kind of write you a samtools command, it would just write samtools sort, and you'd be done there. But we all know that that's not really how bioinformatics works. And so what we do is we, again, leverage the NF Core infrastructure to import modules in. And now, for those that are unfamiliar, NF Core has over 1,500 modules that are live in these production-grade, community-tested pipelines. So if we look at the SAMTool index module here, you'll see that it's used in 45 pipelines that are used by people every day. So the code here is trusted, it's verified, and it's tested, right? And so that's what our system does. And then here, you'll finally see is what it's actually doing is it's actually looking at the scaffolding and is putting the modules into it step by step by step.
What about data side of things? So like this is just going to give you some code, but how are you going to know, like how are you going to actually test if you're building something new?
Yeah, so pipeline mode will generate its own test data. So once this pipeline finishes building over a series of 25 to 30 steps, it will start to generate its own data. Additionally, within Seqera AI, we have SRA search built in, so you can also find SRA samples to download in and then use within your ecosystem. And so we see here that the workflow file for the RNA-seq 3-step has been updated, and we can see that it put it in the include here. When the pipeline is finished, you'll be able to click the download button here, and then you'll be able to run it. So again, what we want to do is we don't just want to put out random code out there that's not going to work. We're putting out code that we're hoping has a much higher probability of working and can run within any environment.
Easy.
Now, I know most people here, they're not on their first pipeline. They're probably working on an existing pipeline already, and they want to kind of use pipeline mode for that. So what we've done is we're given a very easy way for you to give context via GitHub. And so now you can ask any specific task or question that it will do. In this case, though, I've imported a snake-make pipeline that we want to convert to Nextflow. And this is one of the most popular use cases that we're hoping to see for pipeline mode, is to make it very simple for your colleagues that have their favorite pipelines, but are also Nextflow curious and don't just want to kind of go straight into doing it themselves. They can use Seqera AI's pipeline mode to do that on their own. And so what you'll see here is that pipeline mode will git clone the repository, and then it will start exploring it, right? Again, the reason why we're able to do this is because we know that you're on Seqera. We know that you're probably a bioinformatician. We know that the questions that you're giving us are probably around bioinformatics. And when you give us your GitHub, we know that, hey, the questions that you're asking are probably somewhere in here, so we're able to provide answers and code that is much more specific. Now, the last example that I'll show for pipeline mode is something a little bit more specific. So when we were testing this, Evan, we wanted to say hey, you came up with some questions, I came up with some questions, but what about people in the field? Can we survive reality, right? And for us, what we saw was we went into the NF Core Slack channel, and we saw some great questions there. And so here, a couple of days ago, we had a question from Omer, who looks to be living in the future, 9:54 p.m. Okay, very cool. And Omer has a great question, right? How can I add a custom argument to the tool config without changing the original module config file? For example, I want to add -- multi-core 10 to the Bismarck align process. This is a great question. This is the perfect question to use pipeline mode to answer. And so we'll go in here, paste this in, and now you'll see pipeline mode kind of, again, read in the pipeline, and then actually give you a pretty good answer. And so in here, you guys can see, hey, you can use a custom config file to provide an extension argument, -- multi-core 10, and then you can run the pipeline with Nextflow run methyl-seq -c. And so this is all very interesting, but then we were like, okay, but is this right? So when we went into the comments, we saw our very own Phil Yu's GPT also provided a very similar answer. And so we were really, really happy with kind of like what we've been able to accomplish with pipeline mode. Yeah, but I know not everybody here wants to code entirely through chat. It's all very, makes sense. So what I've done is I've taken our variant calling pipeline, so you can see that it's creating the main.nf file right now. And I've downloaded, this is from an earlier run, and I've opened it in my favorite code editor, VS Code. And most of the functionality that we're layering on comes through the Nextflow extension. Now, the Nextflow extension has a couple of really neat things that make developing for Nextflow dramatically easier. Number one is that we have a tree view that shows you the logical structure of the pipeline. Right? This makes it dramatically easier, especially if you're inheriting a pipeline from somebody else, to actually understand what the heck is going on. Number two is we have a list view. Now, this list view is a little bit harsher, right? We see this big red number. I mean, we have a bunch of PhDs here, so nobody here loves to see a 0%. People love seeing 100%, I'm sure. But we give you a way to remedy that, right? One of the things for these processes is we're really trying to push tested processes, right? And so now with the integration, what we provide is a very, very simple way for you to generate files, to generate NF tests immediately inside of your IDE automatically with the help of Seqera AI. And so you'll see that we're trying to make the entire ecosystem of making very good testable code simple. Now, for this process, some of this stuff is a little bit, it's still using a Conda to manage the environment. But let's say that we want to generate, let's say for this, we want to generate a wave container. And so we make that also very simple. By clicking the wave logo, you can generate a container right on the fly. And you'll see here that this is exactly the correct version of Picard, specifically for this specific process. Right? And again, the whole idea here is to make things dramatically easier for the development environment. Nice. Now, Evan, in bioinformatics, things rarely work on the first try. So one of the things is what we want to do is we want to make QA dramatically easier as well. And so some of the stuff that we've also included is the ability to see errors from previous runs. Now, I don't mean to put our colleagues on blast, but it looks like Isha had a failed run a couple of days ago. And so we will try to debug this. And the debug experience in the Nextflow extension is driven through Seqera Copilot, which is built on top of Microsoft's Copilot. And then you can simply ask, hey, can you please resolve this error? And again, it's going to use both the context of the code that is within the code that you have opened and the actual error itself, right? And so again, for us, what we want to do is we just want to make the Nextflow development experience dramatically easier and simpler, especially for those of you guys that are still Nextflow curious and are just trying to come on to what we want to do. Last thing is that everything that I've shown today is available and can be used today. So go ahead and use it. And yeah, happy coding. Yeah, thank you, guys.
Amazing. Awesome. Thanks a lot, Sasha. That's fantastic. It's really great to see like the speed of the development, things are happening here. I can just give a quick summary on some of that things that we saw. So there's the VS Code extension, which you can find through any of the VS Code extension marketplaces as well. It's all available there. Also then, thinking a little bit more about like how we go from both just building the pipelines, but the validation. We saw that you could see how the sort of the use of these tools like this is able to help with creating standards, using templates. This helps and gets you a long way through that. And a big other part of that validation then is really ensuring that your analysis tools, they're not just a script that you run. Like this example that Sasha showed here is able to show that you could use that tooling to make these things reproducible, et cetera. I was speaking to a customer the other day, and they're essentially a bioinformatics core inside of a large pharma, serving around 200 scientists. They have 15 different versions of a single cell pipeline that they had to manage there. And when you think about that, that's like 15 people reinventing the wheel in many ways. And in many ways, it just takes a lot of effort and sort of manual effort to look after all of that. One of the kind of cures for this is, of course, standardization and best practice. It means having like an opinionated way, though, to how you build that. NF Core is one way of doing it, but I'm sure that many of you out there have your own other ways of doing this as well. I think as part of this, though, that it also fosters that collaboration by working together on a singular code bases that we have. It's very easy to kind of pull people along. You get that collaboration in terms of code development, but also visibility into what's happening. And now like your 15 pipeline problem very much turns into like one solid pipeline that 15 people are contributing to there as well. So maybe a bit more kind of practical terms, how we're sort of helping with this. So we're really trying to bake in a lot of the best practices like into Seqera itself. So you can pull pipeline templates, for example, that you immediately start with the gold template there, the gold standard. And then really when it comes to reproducibility, able to leverage containers heavily. So Wave, which we just did a short preview of there. Collaboration built in as well, so being able to share pipelines particularly easier. And just really trying to automate a lot of the tedious tasks which are around in terms of building and validating pipelines. The biggest takeaway, though, is if you can make it like easy to do things like the right way, then everyone will really follow that, almost that path of least resistance. So being able to set things up correctly will be able to pull in more people to support you in those efforts there. Okay, I'm going to jump over now and do a short demo of some of the things that we've had inside of platform and trying to show some of the new things that we've launched recently as well. So hopefully you can see my screen here. Okay. I'm going to start with actually a similar pipeline that we had before. One of the things that we see is inside of the NF Core pipelines, you've got the schema file, and often it's quite long, and it senses exposing every option to the user. That's often not exactly what you want if you want to be able to like simplify things down here. To show you an example of that, this is the NF Core like Molecup pipeline, and here you can see that it's just got really a large number of parameters. How can you really kind of be able to lock that down and also make it easier for folks to do? So what I've done in a screen over here is essentially just take that pipeline, take the Git repository, and I've used Seqera AI to quickly generate for me a simple schema file, like to generate a simple schema file that only has the input and has the method as an enumeration, and essentially creates a drop-down. So what this looks like then is that when I go to launch the pipeline or make this available for others, get a simplified view of this. So here it's now, you can put some documentation there, but I'm really just now selecting which tool that I want to use, selecting my input data set here, where you can either explore on buckets or go through there, and then selecting the output directory. Much kind of a simpler view on that, and it's something I really kind of encourage folks to do as they want to set up and publish their pipelines. Some of the other new things that we've been releasing there is really around having more visibility into the execution of runs. So we've redesigned the pipeline run detail page here. You'll notice that now there's improvements in terms of understanding where you are, the status of a pipeline. So the pipeline bar there, there's also a re-navigation. So like we now have the nav on the left-hand side, try and simplify and bring to the top the things that folks are interested in. And then just a redesign here as well of many of these components, in particular things on the run info page, making the view a bit more rich in terms of where it connects into, whether that's across different compute environments, etc. Another element that we've been building towards is when you are often running these environments, particularly something like AWS Batch, you have this quite long startup period. Sometimes it's taking you 8 to 10 minutes for that initial job to launch. And debugging that makes things quite slow to do that. So we've created a new compute environment, which is in preview now called AWS Cloud. And that runs directly onto like a single VM, the Nextflow job, and it can launch in under 1 minute. So the idea is to kind of speed up that so you get an error faster, and it becomes a little bit more like developing something locally there. So we're going to see some more demos in a moment by a few folks, but I'll just go back to the slides and continue on in terms of the validation aspect here. Okay, it's a bit of a summary there. You've seen like the richer visibility in what we're doing, pipeline management. There's a faster execution via those new compute environments and really being tightly integrated in with the dev cycle. Pipelines themselves are very kind of key part of R&D, but we're seeing more and more bioinformatics pipelines which are being used and becoming really the backbone of like clinical work as well. In personalized therapeutics, obviously this is very clear. Bioinformatics is actually part of the manufacturing itself, but also in terms of regulatory approvals, regulators are really like looking for more sources of evidence for around efficacy and safety, essentially more omics data as part of submissions there. So we've really been trying to support our customers and support really some of the world's leading organizations in moving their critical pipelines into these regulated spaces. And as part of that, I'm going to invite Andrew, who's a Boston local and product manager at Seqera, to come talk on stage.
Thanks, Evan. I am a Boston local, and I am a Celtics fan. This talk is not about the Boston Celtics, although I wish it was. This talk is about moving your R&D pipelines into a more regulated environment, say for a clinical trial or in a manufacturing setting, as Evan referenced. And so, our customers are already iterating on their pipelines in a research environment. There's a lot of flexibility there. It's an agile kind of a development where you can try out plugins, you can bring in your friends on the bioinformatics team, and harden these pipelines over time in a research environment in a flexible way. But our customers asked us, hey, we've got these pipelines, we're using them across many different research agendas. Can we bring these into a more regulated setting, like for a clinical trial or for a manufacturing setting? And we're an open science company, so this question's exciting for us because ultimately we want the impact. We want this science not just to live in a paper, but to also live in medicines that change people's lives. So it's an exciting opportunity. Now, Evan's talked a lot about some of the value the platform already brings. One thing that we should also mention here is that Seqera platform runs on your infrastructure. It's your pipeline code, it's your data, it's your compute, and that gets you in a good starting place. If you have a compliance team in-house, they can really scrutinize the existing research install and get to understand your operation, get to understand what Seqera platform does, and you can work with us to illuminate that even further. So it's a good starting point, but reproducibility in a research setting is a little bit different than reproducibility for a clinical trial auditor, right? So, we have recently added some extensions beyond that foundation that I talked about, right? So one is a modular and installation qualification friendly installer, which allows you to, for your particular environment, have an install that is change control friendly and transparent for auditors. It gets the project started very quickly. We also have added extensions to our audit logging to make sure that basically every runtime state change in Seqera platform is viewable for auditors if needed, if there's any type of anomaly in a trial. And again, that deals with that reproducibility definition being a little different in a regulated environment. And so we partnered with ZS, who's here today, and they've been a great partner. They have the know-how about the regulatory side and the compliance side of things and how to scale your clinical trials or your manufacturing setting. And we have the know-how in Seqera about bioinformatics and Nextflow. And together, we have two specialists on your side that are going to really accelerate this transition. And it allows you to focus on your specialization, which is developing these wonderful medicines that can help patients ultimately in the clinic. And so, if this sort of thing is interesting to you, then, we're here, ZS is here, and we're here to talk to you about it. So come find us. We're happy to talk to you in Slack or in person. And together, let's get these medical interventions out into the world to help our fellow citizens. Thanks, everybody.
Cool, thanks a lot, Andrew. Let's go skip through here. Okay. So on to the final aspect of this, and really kind of talking about scale. And if you've been building pipelines, often not just using them in your own context, but really scaling them up, but also into different sort of areas of the organization in many cases. We've got to start to think about when you're scaling, like how you're going to handle hundreds of thousands of runs in some cases, and particularly even like the validator or the clinical settings there. As things scale up, there is just more complexity. How are you going to manage the costs, manage the failures, and view all that? Also, these solutions need to fit in with various different stakeholders in that, whether that is like scientists themselves or computational biologists or IT teams. Really managing that is kind of a key part of being able to scale effectively. So scaling is not just about performance, like an element of performance, but also about doing efficiently, doing this with visibility, and really, in short, many of the teams are able to access and really kind of access that analysis in a kind of more scaled way. I think one place that we see this starts to break down or see like maybe more fragmentation around this is in data and sort of access to data there. The ecosystem here is pretty highly fragmented. Often experiments are in benchling or like a LIMS system that you have. There's some standardization around this idea of like a data lake. So as part of that, you've got your data in object storage itself, like the underlying files, and there's like a metadata layer on top of that, where it's just kind of stored. This is something like as it relates to Nextflow, like we haven't done a lot of work in this area. It's something that was sort of left up to the user in many cases. But we're trying to change that a bit and try and make some of these data integrations a lot simpler. So as part of that, we're really kind of broadening the reach in terms of data and really doing this through flexible integrations. So these are all Nextflow plugins. Some of them are sort of older than others, but really over the past year, we've seen a big pickup in these, some developed by partners and some developed by ourselves. The way that this works is that Nextflow can really then connect into those data sources, and when you are running a pipeline, you can either query or Nextflow will push, instead of publishing just the file, you're going to publish the file plus the metadata into the relevant format or catalog there as well. When we think about like our roadmap as it relates to Data Explorer, it's really about surfacing some of these objects, so making it easier to link into these existing systems here, to make it very easy to, for example, browse the results of a pipeline, be able to like get a reference into one of those systems, create a data link, etc. Data provenance is also, and data lineage is also a really important part here, and I'm going to save that for Paolo, who's going to be speaking later on today on this, but it's really kind of ties in a lot to this roadmap that we have for this, and really kind of the difference between connecting data in a programmatic setting where you can literally kind of like code this up. It's a little different than what you want to be doing for an interactive setting or interactive environment where you don't necessarily know what data the user is going to want to access beforehand. So kind of building in that flexibility as it relates to data and interactivity is something that we've been doing with Studios. So Studios was made generally available on AWS about a month ago or so. And the premise behind it is we want to take all the cool things that we love about Nextflow, to be able to tie together your data, which is in object storage, reproducible environments, basically being able to use containers for these things, but again, without touching a Docker file, and really running all of that securely in your environment. So 1 year ago, we had Rob come up and give a fantastic demo on this topic. So I'm going to invite him up again. He's going to do a bit of a cameo performance and share some of the new developments that we've had with Studios. There you go.
So thanks, Evan. So we're talking about scale, and we know that running computational biology at scale can be a real challenge. And I think part of the reason why that's a challenge is because the stack is just so deep. If we could switch to the slides for a sec. There's so much to think about. You have a big depth of infrastructure. Then you have, on top of that complex infrastructure, you've got to think about the complexity of the workflows. And then stacked on top of that is the really important bit, which is the biology. And what's really difficult is trying to solve all of those problems at once. One of the things I think that Seqera does really well is allows you to sort of segment out those sections of the stack and think about them one at a time and solve them once, not only for yourself, but solve them once for your team. So for example, compute environments. I'm going to create a compute environment and solve that infrastructure piece. I'm going to customize it and make sure it works in my environment with my data in my compute. I'm going to set it. I'm going to make it available to my colleagues so they can think about the next level in the stack. The pipelines, like the pipeline that Evan just configured. I'm going to simplify it down and take a lot of that complexity away and just provide the people downstream of me with a simplified view so they can really focus on what matters to them, the biology. Pipelines, of course, is a classic example of exemplifying this, solving this problem once. So you've got a pipeline. It's a way of an opinionated way of describing how you want to construct that DAG of connected computational processes. And you solve that problem once, offering the reproducibility and reuse for those that work. And what we found is that interactive work is that last challenge and sort of lagging behind the solve it once mentality of the rest of the stack. And that's really where Studios come in. Studios bring that simplicity of and reproducibility to interactive analysis. So you can spin up environments that are consistent, shareable, and that work on your existing computational infrastructure. Now, I know a lot of you are already really familiar with Studios. Since I was on this stage last year introducing Studios, they've moved from private beta to general availability. It's something you can use today inside of the platform, both in cloud and in enterprise. And we don't quite have time to looking at the clock, I don't quite have time to reintroduce Studios in full, but I just want to give you a really quick tour of 5 of my favorite new features that are new since I last spoke. So if we could switch back to the laptop. Perfect. So here, I'm going to switch to Studios. I have a Selpo Studio here. I'm just going to grab something for the clipboard. So to spin up a new studio, the 5 new features I want to highlight are all involved in the construction of a new studio. The first thing I want to note is when I switch to this compute environment, which is a hybrid compute environment combining CPUs and GPUs, I set, when I created that compute environment, a resource label. And these resource labels are key value pairs. They're going to be attached to every piece of infrastructure that's spun up. So it's going to be attached to the AWS batch jobs. So the admins can set per project these resource labels. I can add my own. I'm going to add a cost center equals oncology. And this is going to be really helpful for me downstream to track exactly how my cloud spend is being attributed. The second feature I want to highlight is this GPUs allocated. It's a simple little text box, but this is hiding quite a significant amount of complexity. Last time I gave this demo, I spent more time than I would like to admit wrangling CUDA, NVIDIA GPUs, software dependencies. To simply say, yes, I would like a GPU is a massive, massive win. Of course, we can mount data in the usual ways, and that mounted data is object storage, and it is represented as local file systems inside of the Data Studio instance. That's really key. The third new feature I want to highlight is the installation of Conda packages here. So I've spent more of my life than I really would like wrangling software dependencies and installing software by hand. I'm sure the same story is true for many of the people in the room. It's really lovely to be able to paste in a Conda environment here. And what Wave is going to do is augment the existing container with those Conda packages on the fly. So by the time it arrives in AWS Batch, in this case, for execution, everything is already pre-installed. Seqera Platform and Studios in particular give you these three options for stabilizing the environments. If you're doing quick and dirty work and you really want to move fast, you can boot up a studio, you have root access, you can, if you want, to do something really detailed and specific, install things manually, and then checkpoint that to Data Studios for your colleagues and yourself in the future. So that's the quick and dirty way. At the other end, for really stable work, you can bake everything inside into a Docker container and then just point the template to your custom pre-built container image. But I think these Conda packages offer a really lovely middle point between those two extremes. So you get the installation of dependencies in the image that you can augment on the fly. Last two features, new inside of Studios, collaboration. By default, these studios are collaborative. They're open to everyone in the workspace, which is great because it means I can share my work in progress and completed my work with my colleagues. But of course, sometimes you want to work with the door closed. You want to make sure that people aren't interrupting your session. You can make the studio session private, and that will ensure that only you can log into this active session. When you're done, you can open it up back to your colleagues. And the last and really important feature that I want to highlight here is these session lifespans. Of course, I have never forgotten about an EC2 instance in my life, and I'm always... Just kidding, I've done it a bunch of times. And I think everyone in this room has at some point had that very late night realization that you've left a 24x large GPU instance running for the day. I can just quickly set a session lifespan, and this can be configured by the admins in the workspace to automatically shut down my instance. It's a really small little feature, but it is a massive life improvement, and I certainly sleep a lot better at night because of this feature. So if I was to add and start the studio, we would boot up a new studio. Because in the interest of time, I'm just going to connect to a studio that I'm running here. So this is a studio that has those Conda environment packages. It's a GPU studio. I can connect to it. It'll look very familiar to people here who were here last year. So I'm going to run NVIDIA SMI just to show that the GPU is actually being used here. I've already manually segmented these images, so I'm going to train a new model based on my manual segmentations, and I can see the GPU spinning up in real time here. And all of the software was installed by the time I started this studio. All the data was available by the time I started the studio. There's no moving data, no installing software. So studios provide this really flexible and adaptable path to scaling your work and your teams. If we could just switch back to the slides now. I'll pass it back to Evan. So it's these really flexible and adaptable path of scaling your work and your teams. We're excited to have it in your hands. And if you have any questions, of course, you know where to find us. I'd be very happy to show you around the data studios and let you have a play. But of course, it's also available inside of cloud and platform right now.
All right, thanks so much, Rob. Okay. So moving things forward, onto the last element here, certainly not the least, talk about compute. And one of the things that we've sort of heard consistently around compute is that it's fantastic to have all these options. And if you've gone into either using Nextflow, you've seen all the different compute environments that you can create. Inside of AWS Batch, the configuration options is just absolutely enormous. For folks who are getting started, though, this can be a little of a pain point. Like, we haven't really necessarily made it easy in the past to make it simple, like an opinionated way to how to do this. Also, on like the cloud vendor side, having to set up an AWS account, do all the permissioning, setting that correctly can also be a little bit difficult and a little of a blocker for people. When we think about that opinionated way to run pipelines as well, a lot of that is around optimization. From the 10 years of working on Nextflow, we've learned a lot about how to run these pipelines more efficiently. It's associated with whether it's the tasks resources, whether it's the instances we're choosing, whether it's spot on demand, et cetera. Managing all of these things really in a way that makes it much simpler for people to get started quick and really to get this optimized experience like right out of the gate. So we have today Seqera Compute, and really the idea of this is like to remove a lot of that infrastructure headache that exists with folks. We're super excited to announce that this is coming out in public preview today. So you're able to apply to run this here. The whole idea about it is it's trying to make it a very simple, optimized compute environment, both for Nextflow pipelines, but also for interactive analysis. It comes with its own storage bucket. and it's really kind of backed up by AWS on the back end of this. You can literally go from zero setup to completely running a pipeline in a few clicks in minutes as well. And there's a ton of cost optimization that we've been building into this, really to stop any kind of the idle servers or any of the kind of issues it's going to see as it relates to that. End result, faster pipelines, lower cloud bill, and really get started with zero infrastructure maintenance on your side. I want to touch a little bit about what that looks like behind the scenes, and this is something that we've been sort of evolving over time. Really, how can we put those optimizations there, both for Seqera Compute, but also for customers more broadly? One of the things that we see is the task request sizing. So very often you'll be requesting much more resources than you actually need, both in terms of CPU or memory or GPU. So being able to do that in an efficient way is something that we've sort of built into the back end of this. Also, instance utilization. This is a view of two virtual machines, and you'll see that very often in sort of batch services, there's a significant number of jobs that are working at the start of the execution, but then over time, maybe you've got some longer running jobs, the virtual machine stays around, you're really paying for all of that usage unnecessarily. Of course, there's Fusion, and we'll hear a bit more about this later on, but this is kind of the way that we're able to directly mount object storage in there and not have to wait for this time for the files to move up and down. You essentially can operate on them as if they're like a local file system. And then last but not least is this spot instance reclamation. We've seen that in the spot market today, there's a lot more spot reclamation taking place. This pipeline here, I believe it was around 40 to 45% of the instances got killed at least by one time from spot reclamation. And with the snapshot feature that we have, we're basically able to snapshot the whole virtual machine, put it onto a different one, and then those tasks obviously just continue from there. So all of that, all those optimizations are built into Seqera Compute, and also kind of coming to other folks shortly as well. Wrap up on this. So if you're interested in requesting compute credits, you can hit us up there. Also available on the website, and there is a new page for this as well. Okay, so summing things up overall, I hope you've sort of enjoyed and seen a lot of the new things that we're coming up. A lot of exciting stuff that's happening in terms of Seqera side, really ramping up in terms of working with customers as well on the validation side. I hope you enjoy the rest of the talks that we have today. Some ones that we're going to have from Seqera. We've got Paolo, who's going to be talking about what's new in Nextflow. We've got Isha, who's talking about how to scale with Seqera. And finally, we've got Edmund, who's going to be talking about NVIDIA and Parabricks for some of these pipelines. I'll leave you with one message today. I think we live in an incredible time. The possibilities for discovery, for development, right? They've never really existed like this before. I think the investments that you're able to make in software, but most importantly, your teams and your education there, will really unlock that scientific creativity. And as that sort of scientific software becomes an enabler, we're really going to see massive advances over the next decade. So thank you very much for the time, and please come say hi. Love to chat with you all.